Hello and welcome to United Astronomy Clubs of New Jersey. So, while we're waiting for maybe a couple stragglers to file down and find some seats, and also, it appears we're still setting up. Lonnie, if you could just move your mic slightly below your mouth.
Okay.
There we go. Right. So, welcome in. Thank you all for joining us. If you For those who are here, if you ever can't make it back here, you can always join us online because we do live stream these on YouTube and Twitch. And if you've ever find a program on our website that you've missed and you're like, man, I really wish I could have watched it, you actually can because you can check that program out through our archives on our YouTube. In addition, do check us out on our website, uacnj.org. That's where you're going to find a list of all our programs we've had this season, as well as the programs we have coming up. Speaking of programs, we actually have a special event program next Saturday that will be going. Hello. There it goes. 11 a.m. to 4 p.m. That's right. We are going to be open for the annular solar eclipse, or at least what we can see of it through New Jersey. We are in the 25% visibility band, so it won't be the full annular eclipse that you might see if you're in the southern United States or Central America and Mexico, but it'll still be fun and entertaining. You can also check us out on our social media pages, Facebook, Instagram. We have a Discord channel, so do check us out there. And we want to thank everyone who's joined us there and liked and subscribed to our pages because it does let us know we are doing a good job. And with that, we come to our safety briefing for those of you who have joined us here in Jenny Jump State Park, because yes, it is that inescapable time. If you need to use the restroom, it is the porta potty in the back to my left, your right. Yes, reversed because you're looking at me. In addition, we do have a museum and gift shop area that I'll be manning after the presentation because still, they will not give me the technology to be in two places at once. I heard giggles. Mostly moms, I think, going, man, yes, I could totally take over the world if I had that ability. But that is not what we're here. So we're not planning world domination, but when we do go to leave here, because it is quite dark, because it now gets dark early, we are using our headlights when we go to leave because we do not want to run people over. There is not 10 points for each pedestrian and volunteer. Please we want to stress safety and make sure everyone gets back to their homes. That being said, if you do have a flashlight, do keep that pointed towards the ground because we don't need people accidentally blinding other people. Because night vision takes time to develop. And with that, our program tonight is an ongoing series we have that goes over what you're going to find up in the night every month. Because as we rotate and everything else rotates, everything's spinning all the time, it does change. Giving this presentation is Lonny. Lonny Buinis has been presenting What's Up in the Sky at UACNJ since it opened in 1994. He's been an amateur astronomer since age 10 and still going. He hopes to make it to the next viewing of Halley's Comet in
2061.
I should remember that by now because I say it enough. But he does have 2 degrees from Stevens Institute of Technology in physics and computer science, but thinks practical experience also has a lot to do, and he does space art, space animation, and virtual reality objects. Lonny has written a interactive astronomical history book, Space History Mystery Solved, which he will shamelessly plug later. But I can't fault him. The best decision he says he's ever done was to marry his narrator, who Jan, who keeps his feet on the ground while his head is high above the clouds. With that, Lonny.
Thank you very much, Kim. It's great to be here. Thank you all Wow, I don't know if I deserve that. I have to give you a warning first before we start. I am not a professional astronomer. I do this not for money, but for love. So tonight, I'll be telling you lies and falsehoods, one after the other. See if you can figure out if anything that I say is true. Challenge to the audience. There's no penalty for challenging the speaker. So if you have questions, also save them for the end. Kim will actually hand you the microphone so you could ask your question, and people at home can ask too. It's great to be here. This is what we're going to see up in the sky, and it's actually clear tonight. So if you either look up right now, you'll see a tent. And if you look over here and go outside of the tent, either do that or look here, you'll see this great big square in the sky, which has been very imaginatively named by astronomers the Great Square. Yeah, astronomers have tremendous imaginations, as you can imagine. We're going to look for that Great Square to help us find the most distant thing in the universe that you could see with a piece of equipment that you were born with. And that is that I'm going to use the technical term now. You ready? I want everybody to remember and repeat after me. Naked eye. Tremendous. Oh, you guys are less shy than the usual audience. I am myself a very shy person, believe it or not. And for over many years, other layers have been added so that people are like me are like onions. You know, in the core, there's a shy person in here. And I know that some of you out there might be shy, so don't be. Feel free to join in, ask questions, and doubt everything I say. So let's get started with some stolen property recently returned. Did you hear about this? No? Yep. The Origin Spectral Interpretation Resource Identification Security Region Regolith Explorer OSIRIS-REx space probe stole a piece of the Bennu asteroid. Did you hear about this? And it brought it back to Earth after years. It's a little piece, about 250 grams. That's about 9 ounces. You can hold it in your hand. But it's extraterrestrial, and it dates back way back, they think, to the beginning of the solar system. So it's going to give us a hint of what was happening back then and how we evolved, how we came to be, how the Earth came, perhaps. And that's an actual picture of the space probe that returned and landed on Earth with the sample. That's the parachute. OSIRIS-REx, it's a long name. That's the acronym. Also, today, if you look up at On This Day, if you want to know what happened on this day, you go to onthisday.com. Brilliant name. James Webb. He sounds familiar. He was born this day in 1906. Why is he famous? Yes, the telescope, the James Webb Space Telescope, JWST, right? You hear them say that? Exactly right. Thank you. Yep, the telescope is named for him. He was administrator of NASA in the 1960s. And also on this day, for the first time, we got a picture of the other side of the moon, the far side, which is always dark, right? No. Nope. Every part of the moon gets light from the sun. It's just that we don't see half the moon because the moon always faces us one way. It spins around once every 27 and a third days, and it goes around the Earth every month, 27 and a third days by the stars. If we measure it by the sun, it's 29 and a half, and our calendar ranges from 28 to 31, right? But that's what it looked like. There is Tsiolkovsky crater, the only really well-defined crater, the one well-defined crater on the other side of the moon. We on our side, the side we see, that has those dark seas, frozen lava seas. Not so on the far side. That's what it looked like to the Luna 3 spacecraft in 1959 on this day. So, here's what we're going to test you on at the end. I see everybody furiously scribbling notes on their iPads? No? Furiously. Very good. We got a very enthusiastic members of the audience in front. I want to see everybody with that level of enthusiasm. Shy people in the back? No? All right, so let's start with meteor showers. We've got two this month. Did you know? On October 7th, that sounds familiar. Today, thank you. You see, these people aren't shy. You can be like them. It's okay. October 7th, there is a meteor shower going on. It's leftover debris from a comet. Every year, the Earth goes through the track that the comet followed in its orbit around the sun, and it left some debris, some dirt, little pieces that burn up the atmosphere. How big are they? Fist size? Boulder size? Nope. No. Sand grains. Yeah, exactly right. Yeah, about the size of a grain of sand. They burn up 20 kilometers a second times 0.6 is quick. Mathematicians in the audience. 12 miles an hour. Second, 12 miles per second. That's pretty fast. And sometimes, every once in a while, these will peak to thousands per hour. But this is a weaker shower. And typically, you might see one meteor over the course of an hour, but you have to be patient. It's from comet Giacobini-Zinner, and it's called the Draconids because they seem to spurt out of the head of the dragon, Draco. Why do they come out at all angles over the whole sky? If we're in a parallel track, then it must be like a railroad tracks or those annoyingly close markers on the Garden State Parkway. Very close together, right? But they seem to meet in the distance. It's an optical illusion. So the meteors are coming at us all parallel, but they seem to come out from one place in the sky. We have a better one than this, but tonight, if you, after I finish speaking, if you go out and look towards the north, over the building here, you'll see the Big Dipper. Thank you. Thank you very much. We have to reward this member of the audience. Pointing to the Little Dipper and nearby the head of Draco, or Draco, where the Draconids come out. We got two phases of the moon, new and full. One of them is great for seeing faint objects and one is not. New moon. Where's the new moon in the sky? You can't see it. It's too close to the sun, right? It moves right over or under the sun. Why don't we have an eclipse every time there's a new moon? Oh, this is a trick question. Yes, because right. You got it. Goes under and over because the moon's orbit is tipped to the Earth's equator, 5 degrees. So we have to wait for the whole orbit to spin around for the eclipses to line up. So we've got the new moon and an eclipse, and they are our amateur astronomers like Kim here are going to be helping out. If you come visit, you can see a partial phase. It looks a bit like Pac-Man, but never ever look at the sun with your naked eye. You can damage your eyes. Good time to see faint objects is now. Horrible time is the full moon, just blots out all the faint objects in the sky. That's the 28th, toward the end of the month. And there are all the phases of the moon, the good ones, the important ones, at Moon Giant. Moongiant.com is a very good place to get information about the moon. You can even print a calendar. Moongiant.com. All the main phases, I put boxes around them. You can put up all the illumination angles and the phase names, but we just have the most important ones. Last quarter, new moon we saw, first quarter and full we saw. Now, when's the best time to see shadows on the moon? Full moon? Nope, because the sun is behind you, and when you shine, like you shine a flashlight on something directly, no shadows, can't see any details. So the best time, I think, is the first quarter, not the last, which is yesterday. And even now today, just past last quarter, we have a crescent moon. good to see shadows. Why? Because the sunlight's coming in at an angle. If you want to do that at night, this is early in the morning. The first quarter phase is directly in the south, which is that way at Jenny Jump, as the sun sets. You can see the first quarter moon even as the sun's setting in the daytime sky. So, good time to see details if you get up early. 5 in the morning, 6. New moon, faint objects, full moon, nothing. Well, stars, double stars, planets. First quarter moon, details. And there is the first quarter moon. That's what it looks like tonight. And this was earlier. And I'm using a computer program that's free, which I'll talk about in a few moments, to simulate the sky. What's this teapot-shaped group of stars called? Anybody know? It looks like a teapot. It's got a look. See the spout, lid, handle. You'll never guess. Teapot. Yeah, I'm not kidding. That's exactly what we call it. So we were talking about the moon, phases of the moon. Every month, the full moon has a special name, and this one is the hunter's moon. Good time to hunt because there's no leaves. Prey, animals can't hide in the fields. It's easier to find them. Time to start storing food. You see the squirrels out. We've got this big one in the backyard, our backyard's getting ready, storing nuts and stuff. Nuts and stuff. That sounds like a good name for a health food store. Okay. So we've got different names. The nuts moon. I've never heard the nuts moon, the leaf falling moon, the blood moon, the autumn moon, the pumpkin moon. Pumpkin moon, that makes sense. Good moon to drink pumpkin lattes by. We have the annular solar eclipse the same time as the new moon because the new moon lines up, goes right across the sun partially, kind of over the bottom, looks a little like Pac-Man. Don't know if any of you know what Pac-Man is anymore. It was an old game, right? Ancient. I was alive when Pac-Man was invented. The time of the dinosaurs. We have, thank you, the gentleman there simulating the sound. Thank you. Solar eclipse. So you can come here to view that safely. Again, safely with our equipment. We put filters over the telescopes. Do not, I repeat, do not look at the sun directly. Use special glasses or filters. And that's what it looks like. Can we have the sound again, please? There you go. Thank you. And that maximum happens about 1:20 in the afternoon. That's the view from about here. October 14th, don't miss it. Here's where you have to be to see the whole thing covered, right? So the western United States or Mexico down here in South America, and it would look something like this. There's a thin annulus, thin ring around the sun. The word annulus means ring. The word annular means like a ring. And that's, you can simulate this at timeanddate.com. They have a simulator where you can drag the controller on the bottom and watch the whole eclipse happen. Really cool, and it's free. Timeanddate.com. Check it out. We've got the partial lunar eclipse on October 28th. This is where the Earth's shadow eclipses our moon. The moon travels around the Earth, can go into the Earth's shadow. Unfortunately, this is a penumbral eclipse. The Earth's shadow has a deep part, the umbra, and the part outside the umbra is called the penumbra, and that's where the moon's going to pass, unfortunately. The penumbra is very weak, so you might not notice that part of the moon on the side at 6 p.m. on the 28th looks a little dimmer. I challenge you to see it if you can. That'll be at 6 p.m., where we probably can't see a thing because it's so bright out. And this is what it looks like simulated. There's the part of the Earth's umbra. There's the penumbra. And this is the reason why about 3,000 years ago, the ancient Greeks knew that the Earth was round. They saw the moon go into the Earth's shadow, and they said, oh, the moon must be round, and the Earth is casting a round shadow. To this day, there's a society called the Flat Earth Society that still doesn't believe that the Earth is a round ball. Finally, if you missed the Draconid meteor shower, you got a second chance. The Orionids is a bit better. October 21st, it's good if you stay up late. Best time is around midnight when we're looking right down the Earth's shadow. If you can't stay up that late, look earlier for the Orionids coming from, you guessed it, the belt, right? The Hunter, the bright star Betelgeuse. The what's Betelgeuse? It's the, well, when I was a kid, they told me, to be polite, that it's the shoulder of the giant, literally translated. And I looked it up when I was an adult. I was delighted and also disappointed to learn that that was wrong. It's the armpit of the giant. Yep, literally, Betelgeuse, Betelux, Betelgeuse, there's about 5 ways to say it, is the armpit of the giant. Rigel, bright blue star, used in Star Trek, the Rigelians. Look for Orion, you'll see meteors coming out all over from Orion over the whole sky. If you want to see these, about 20 an hour, so you might see one bright one over the course of an hour, where do you look? Up. Thank you. You don't look at Orion. You lie back on a comfortable chair. So you need a chair. You need your, nope, no binoculars, naked eye, thank you. And you don't need bug spray. Yay. So that's it. 2 pieces of equipment to see meteors, and you want to look over the whole sky because your eye has a wide angle. Astronomical telescopes have a 1-degree field of view. The moon is a ½ degree, so it's only 2 moons. You're going to miss everything. Binoculars are a little better, right? Several degrees. Still, not so good. And this is debris from Halley's Comet. Anybody hear about Halley's Comet? You heard one of the most famous comets. It's coming back again. It was here in 1984. I saw it, and I hope I'll be alive to see it again in 2061. Yeah, thank you. Yes, Mark Twain, Samuel Clemens, the author, Mark Twain, was born in the 1800s when the comet came by, and he said, I came in with the comet, I'm going out with the comet, and in 1910, he died when the comet came back. My grandmother was alive in 1910. She was a teenager, and she saw the comet tail from the horizon to the zenith. It was 90 it was incredible. It occupied the whole sky because we passed through it. We went through the tail of the comet. It was so close. Now this next time, 2061, we're going to be far away from the comet. So I'm going to miss it. And the time after that's going to be great, but I'll be long dead. And so will all of us. I don't want to depress anybody, but it takes 76 years each time for the comet to come back. So I hope you're not all depressed, but we will see it. We'll see. No, don't be depressed. Finally, the planet Venus is west of the sun. Now, if I face south at Jenny Jump, the sun sets in the west that way. If Venus is west of the sun, what time of day or night are you going to see it? You can see Venus only right now as a morning star, morning, west of the sun. The sun will be rising in the east. Venus is west or right of the sun. Morning star. It's brilliant. It's so bright it can cast a shadow. Did you know that? The only planet that can cast a shadow, besides Earth. Well, the only one that casts a shadow on Earth. And this is a simulation of what it looks like in the morning sky right next to the constellation in the zodiac that looks almost like what it's supposed to be, with a tail and a big mane on its head and a bright foot star. Leo the lion, thank you. Oh, your sign is Leo. Mine is the sea goat. I'm embarrassed to admit it's a half fish, half goat. Capricorn, yes. Except that that's not where the sun was when I was born. The sun was in Sagittarius. Astrology is off by an entire sign in the 3,000 years since it got started. Right now we're looking at a blank screen because I want to show you Stellarium, which is the free program that you can get. and you can install it. You can run it off a website. You can use it on your mobile device. And it looks like this, simulating the sky the way we see it. I can do weird things, though, in Stellarium, like I can zoom in to look for these famous 7 stars to help me find north. We know what that is, right? Big Dipper is correct. It's part of a constellation that looks like, does it look like a bear, you think? What if I take Ursa Major's picture away and I just draw lines, head, claws, tail of the great bear? Wait a minute. Do bears have tails? Not anymore. No, no. According to Iroquois legend, a brave warrior captured a bear by the tail and hurled it into the sky. It was a short, stubby tail, but when he was done, it got a little longer. Follow the Big Dipper's pointer stars. 5 times their distance apart. You will just miss Polaris. Polaris, the pole star. Why is Polaris important? Because it's right near my arrow, right there. Yes. It's the North Star, and it helps us find north. Why? It always faces north. The Earth, as it spins, has a north pole and a south pole, and that's where the Earth is pointing right now. Didn't always point there. About the time of the Egyptian pyramids, when they were built, this was our pole star, Thuban. That's where the Earth's north pole pointed. And in about, let's see, 10,000 AD is 8,000 years from now, it's going to be the bright star Vega or Vega. Someone in the audience last time asked me, and I didn't have an answer, so I looked it up. Is there a south star? And will there ever be a bright south star? The answer to the second question, yes, there will be. I just don't know which one it will be. I'm going to have to run a simulation to find out. But right now, the south star is Sigma Octantis in the octant. Any sailors in the audience? You know what an octant is? It was replaced by the sextant. It's a device for measuring angles in the sky. It's used in navigation. The octant became obsolete when they invented the sextant, but it can still be used, still useful. So there's a southern constellation, the octant, and there's a little star, magnitude just 5.5, just barely visible to the eye. We're lucky. We have a second magnitude star, much brighter, called Polaris, easy to find. So now that you've seen these stars in the north, you've got 3 constellations that never rise or set. They're always there. They can help you learn the sky. That's how I got started. I got myself a star map. You can get them in magazines like Sky and Telescope or Astronomy. You can get them online at those websites. You can buy one here. Kim is going to show you one. We have rotatable star maps. Our model is showing you our star map. Yes, cheap and very convenient. They're easy to work. They show you the sky any time of year, any time of day or night. The last 2 stars that never rise or set, constellations, the Queen, Cassiopeia, and the King Cepheus. But the interesting part of the sky, and I can make Stellarium look like one of our planispheres, I can move over to the west where stars are disappearing. If you want to see the stars of spring like Hercules disappearing in the west, you've got to look quickly before things go down. I see a question from the audience. The Greek legend of Hercules? Yeah. Oh, Heracles. Thank you. Yeah. There are different cultures and different names. And actually, if you use the program Stellarium, you can actually see ancient Indian, ancient natives to Mexico, or European legends, all kinds of cultures. The standard is the Greek mythologies, but it's not the only one. If I move over from the west, low in the sky, I can see the 13th sign of the zodiac. Did you know there's a 13th sign? Yeah, it looks like Ophiuchus, the spelling. believe it's pronounced Ophiuchus, the serpent carrier. And he looks, if you draw him, one drawing looks like that. The serpent is split into serpent's cauda and serpent's caput, head and tail. And the planets, the moon and the sun, partially move through this constellation, a part of it. So there are now 13 constellations, not 12. This is where the sun was when I was born, and this is my sign. So astrology is off by one sign. I believe some modern astrologers account for the precession of the Earth. The Earth wobbles like a top running out of energy. Don't worry, it won't run out of energy anytime soon. One wobble takes 25,000 years, so it's very slow, and that's why our pole star changes very slowly. If you want to see the stars of summer disappearing very quickly down in the south, you can still see the teapot-shaped group of stars called the teapot. Thank you. Yeah, no need to be shy. Just shout if you know. Also called Sagittarius the Archer, half man, half horse, which is called a centaur. Thank you. And if you look here at Jenny Jump on a dark night in the summer, along the steam coming from the spout, that's the Milky Way, our galaxy of 1 trillion stars. You can see a little detached piece of the Milky Way that's not the Milky Way at all. It's a stellar birthplace, a nebula called the Lagoon Nebula, with a lagoon of dark dust running down the middle, bright hydrogen gas glowing red, that characteristic color. And nearby another nebula, the Trifid, or Trifid, 3 lobes, also glowing blue from the light of hot, young blue stars burning their energy out in no time. They live a fraction of the lifetime of our sun. They burn out very quickly, only a few 100 million years. Yeah, very fast. The sun goes for thousands of millions of years. But those blue stars light up the hydrogen gas blue. So there's beautiful colors when you take pictures of these nebulae, which is plural for nebula, a gas cloud. And are we going to see that in a telescope? No. We're not going to see those colors. The human eye can't see colors too well at low light levels. It's all going to look kind of green. But it is cool to know that that's the center of our galaxy, right in this direction. There's a supermassive black hole right there. Can you see it? No. Why? Why can't you see a black hole? Because it's black. It's black. Right, yeah, it absorbs all light. Nothing can get out. Even light. Light, when it moves, photons have an effective mass. They have mass energy. E equals mc squared. So E divided by c squared equals m. Right? E over c squared. That's an effective mass, a mass energy. And photons have it, even though they have no mass when they're at rest. No mass at all. They're the light among the lightest things in the universe. Also, gluons have no mass. So they get sucked into a black hole, and we can't see it, but it's in that direction. If you come to Jenny Jump here and look over the whole sky, up and over, you'll see the Milky Way rise from the south all the way across the sky, over past Cassiopeia, the W, or Queen. Very cool. This is one of the darkest sites in New Jersey. We're privileged to have it here. It's all run by the help of amateurs like Kim, and Chris is behind the scenes helping us. We got Paul. We got a lot of amateur astronomers who dedicate their time for free, very dedicated. All I ask is that when you go to look through their telescope, please don't kick the tripod. Don't kick them out. You'll make an astronomer cry. Go up higher, look higher along the Milky Way, and you'll see the 3 bright stars in the summer triangle. Brilliant name, triangle of 3 bright stars, summer triangle. Who would have guessed that they would have come up with summer triangle? I don't know. I would have called it the approximate polygon-shaped group of bright summer stellar objects. But that's kind of long. So summer triangle's pretty good. Three different constellations. Altair in the eagle, right there. Vega in the lyre or harp. And Deneb, the tail. Oh, Deneb, tail, in the swan. Well, we heard Deneb already, tail. And there must be a head. If there's a tail to the swan, there must be a head. And this is one of my favorite stars. Look for the head of the swan sometime. Well, now is a good time. Tonight, ask one of our amateur astronomers to show you the star Alberio. This is a beautiful double star. There are stars that revolve about each other. These have two different colors. Not well seen in a computer simulation, but in the real sky, this is one of the most beautiful double stars of all, gold and greenish blue. Absolute striking to the human eye, to the naked eye. Check it out. If you have your own telescope, just defocus it a little bit. You'll see the colors more easily. I see a question. I'll tell you what, we don't have time for questions right now, but can you remember your question for later and we'll make you the first one? Thanks, because I am going to get through a lot, because you don't want to hear me blather all night. You want to go out and look at this stuff before it sets into trees, right? So please hold that question. That's a good thought. So check out Alberio, check out the Swan. There's a lot of nebulas in this area of the sky. And right there is the first discovered X-ray source, Cygnus X1. It's something falling into a black hole, another star being torn apart. Can you see it? No, no, you can't see a black hole. It's too far away. Summer triangle. And before we wrap things up, I want to show you this huge square in the sky, very imaginatively called the Great Square of Pegasus, the flying horse. Pegasus got chopped in half, ouch, to make Andromeda the princess. Poor Pegasus is upside down, chopped in half. How you'd like to fly upside down, chopped in half? No, no. But if you find the star Alpheratz, Alpha, the bright star in Pegasus, and go 2 stars over and 2 up, you will find the farthest thing that you can see in the universe. It's in the Guinness Book of World Records. And that is the Andromeda galaxy. And it looks just the way our galaxy would look from Andromeda. If you went there and looked back at the Milky Way, you would see a flattened disk of stars with 2 bright companions, little satellite galaxies. You'd see dark dust hiding the starlight behind, old red stars toward the center, glowing hydrogen gas, glowing from the young blue stars reflecting the light. This galaxy has more than 1 trillion stars. It's bigger than ours. And right now, right this very moment, we are on the way to meet that galaxy. We're going to merge with it. Not really collide, just merge. And don't worry, it is going to happen fairly soon. But we've got it. We know almost exactly when. Be about 5 billion years from now. 5 billion, yeah. Yeah, it's very soon. The whole universe is anywhere from 14 to 27 billion years in age. New figure just figured out the universe might not be 14 billion years old. There's a new estimate, 26.7. Who knew? So that's what our galaxy would look like. And we have 2 little satellites that some of you may have seen if you visited South America or Australia or Africa. Anybody ever see these 2 little galaxies? Magellanic Clouds. Look them up. Magellanic Clouds. And that's in the Andromeda Galaxy. So, when you go outside, I'm going to do a quick review now in case we have questions later. I would start in the north, work my way to the west, look for the stars of summer disappearing, Ophiuchus, the Serpent Carrier, the Teapot, the Milky Way, and then to the left, well, that's my sign, kind of looks like a couple of triangles. That's the sea goat, Capricornus. Oh, I almost missed something very important. Very bright star-like object that's not a star at all. Saturn. Look how far I have to zoom in to see anything. I can barely make out rings the way Galileo did 400 years ago. He thought Saturn had ears. Ears. He couldn't tell that it was a continuous ring all the way around the planet. That's what it looks like in a small telescope. The rings are open right now. They seem to do this over the period of Saturn's orbit around the sun every 29 years. So half of that, about every 14.2 years, the rings disappear seen from Earth because they're so thin. They're only 30 feet thick and yet about 170,000 miles wide. Saturn itself, the disk, is 9 Earths across, 9 times the size of Earth. In larger telescopes, we can see that there are thousands of ringlets, hundreds, over 100 moons. Last count about 162, and so many more mini moons inside the rings. Might have been a satellite that broke up. You can see that even in a small telescope, you can see details on Saturn. Saturn is in Aquarius, the water carrier, sign of the zodiac. When we say Saturn is in those stars, what do we mean? Is it right by the stars? Very far away. Saturn, the light from Saturn here left about an hour and a quarter ago. The light from the stars dozens to hundreds to thousands of years ago. That's how slow light is. When you look at the sky in different parts of the sky, you're traveling back in time different amounts. When you look at the moon, you're looking at the moon as it looked over a second ago. When you're looking at the sun, 8.3 minutes ago. When you look at planets, anywhere from 15 minutes to hours ago. The stars, hundreds of years to thousands of years ago. When you look at the center of our Milky Way, that's 30,000 years. So you're time traveling every time you look at the sky. Another great reason to get inspired to look at the sky. It makes us, sometimes it makes us feel small, but it also can expand our minds. It's a lot of fun. While you're there, look up high in the sky. This is the clearest part of the sky because you're looking through only 5 miles of the thickest part of Earth's atmosphere. The atmosphere interferes with good seeing. All right, coming up bright, you want to look down low, and you'll see a very bright object in the east. In fact, you can see it right over there, right now. Look to your right. That's not a star. That's the largest planet. Jupiter, correct. Yep, looks like a very bright star. Jupiter is in opposition right now, same side of the sun that we are on, so it's closer to us. It is 5.2 times as far from the sun as we are. So 5 minus 1 is 4. 4 astronomical units away. Multiply 4 times 93 million, about 400 million miles away. So each astronomical unit, about 8 minutes. 4 times 8, 32. You're looking at Jupiter as it looked a half hour ago. Quick calculation. All of the moons, the bright moons of Jupiter, well, 3 of the 4 big moons are visible right now. This one I'm very excited about. Europa is covered with ice, but inside we know there is a warm ocean and organic matter. So there may be advanced life inside Europa. And that is one of the places we're sending a space probe to dig in to a thin point in the crust to see if microbes percolate up. There may be even more advanced life. At the juncture of the ocean, the oceanic plates on Earth, we have blind crabs and tube worms and shrimp that live in freezing temperature waters, but at the smokers, where organic matter comes out, 400 degrees. And they can live on that stuff. It's incredible. Is that Ken over there? So I'm going to wrap things up. That was our quick review. We're going to end by looking in toward the east. Whoops, I went too far. Toward the east, you would expect the stars that I'm going to talk more about next time. Pegasus, the great horse, in the Andromeda Galaxy, and Pisces, the fishes. We'll have a better view because they'll be up higher the same time, this time of night, next month when I talk about what's up in the... I don't hear the people in back. November sky, thank you. So before we end, let's get back. And I want to give you some references. So, free program, Stellarium, that's what you saw me using. Stellarium.org, you can download it, you can install it. You don't want to do that, you can use their supercomputers on their website, stellariumweb.org. You can get Stellarium free, completely free for your mobile devices. Celestial lets you fly through space. You can see what the eclipse coming up on the 14th looks like from the moon, where the Earth blocks the sun partially. Celestia. You can use binoculars like I did for my dog. Yeah, these you can actually wear. They make wearable binoculars. That's a good way to get started because if you get bored, you can use them for other purposes, like bird watching or spying on your neighbors. No. You can buy inexpensive telescopes. Actually, the prices have come way down. When I was the age of some of the people in the audience, telescopes were $200 on up. Couldn't afford it. Now you can get a Celestron First Scope for about $67 plus tax. Great way to get, if you can spend a little more, you get more light from bigger telescopes. A good design is a Dobsonian. It's called the Dobsonian, named after a person named Dobson. And it gets you more light grasp, and it uses a very simple mount. That's a Celestron. There are many, many brands of telescope. I believe we sell one here in our gift shop. United Astronomy Clubs of New Jersey. Repeat after me, UACNIJ. Right, uacnij.org. We're everywhere online. You can still read magazines. Yes, they still print magazines. Sky and Telescope Astronomy. They have online parts that are free. You can subscribe also for more information. And please, if you forget everything else I've said tonight, you can even forget my name, Lonny. Just please don't forget UACNIJ and don't forget space.com. Easy to remember. They've got a lot of good reference. And so I give you a quick review of what's up in the October sky. 2 meteor showers, 2 phases of the moon, time to see Venus in the morning, and the Orionid meteor shower. That's a good bet, October 21st. Don't miss the lunar eclipse, and come here for the annular eclipse. Thank you. This is where you can find me. My website, Astronomy in Motion. Mars at your fingertips. You can buy my 3D model of Mars. It's cheap, or you can get the free samplers at Astronomy in Motion. And I've taken my book out of circulation because I'm trying to get it published by a publisher, but I'll talk more about it next time. Thank you. You have been a terrific audience. Hope to see you again.
All right. Thank you, Lonny. So we are going to be doing a question and answer session as promised. But first, because I noticed a couple of you sneaking in during the presentation after the safety briefing, and it is unescapable that I do have to do a safety briefing for everyone. So, if you need to use the restroom, that is the porta potty to the back, to my left, your right. We also have a little gift shop and museum area that you can check out that I'll be manning after the presentation. When we go to leave, it's dark. We are using our headlights. Use the headlights, please. We do not want to get run over. We do not want to see anyone get run over. That being said, if you have a flashlight, do keep that light pointed down because we don't need to unnecessarily blind people. So, for the question and answer session, for the people here, you have the harder part because you're going to have to raise your hands and kind of wave them in the air like you just don't care, because I am like a T-Rex in the dark with no night vision since I've been monitoring chat looking at a bright screen.
And Kim, if I can interrupt for just a second, there's a gentleman here on your right who had a question earlier, and I promised him that.
Blue sweatshirt, red blanket?
Yes.
Okay. Well, I'd like to make sure I thought I had made a mental note. So, all right. So, first question is going to go to him. Hold on. We want to use the microphone because some people might not be brave enough to ask their question.
Do you believe in aliens?
Do, do I believe in aliens? Now, there's different ways to interpret that. So if we go by the okay, do I believe in aliens or life forms, extraterrestrials, let's say. So if we go by evidence, and you'll see this on YouTube, scientists don't like to be nailed down. They go by evidence. What do we know right now? We know that there is lots of frozen water on Mars, and there were conditions on Mars that made life possible early on. So we might find some fossils there or microbes. We may find advanced life inside the moons of giant planets like Europa and Ganymede by Jupiter. Saturn has Enceladus, where we see geysers coming out, and so that's a good place to check. So if we go by evidence right now, we have to say we don't know, but I do believe that our galaxy to start with is littered with intelligent civilizations, not just any kind of life, but people, because there are the possibility of 10 billion planets like the Earth in our Milky Way alone, and that's not counting life inside the moons of giant planets around those stars. So I believe there could be tens of billions of advanced life forms just in our galaxy, and we know that there are trillions of galaxies. So yeah, the quick answer to you is yes. Yes, I do believe in aliens.
It is statistically improbable that we are the only living
Yeah,
beings.
I have to also add that the processes that made us on Earth, amino acids forming DNA, you'll see many skeptics say you couldn't have this happen by chance. DNA is too complicated. Well, yes, of course. That's not how it happened. It happened through a series of connections. Everything is connected in the past. The sequence which made us, you can find those organic components in our solar system everywhere. You can find it in interstellar space. You can find the energy that puts those components together. I think we're going to find DNA everywhere.
All right. So, our first online question. I can skip over my reminder to remind you about asking about the South Pole Star homework. The first question online is: do we have better pics of the dark side of the moon now than the one you
Oh,
showed us?
yeah. I showed you that first picture of the other side, not dark, but the far side. Yeah, we have there's a NASA probe that was orbiting the moon that mapped most of the far side. And it's interesting because it's missing most of those dark seas where there's extra mass that got attracted to Earth over long periods of time. So it froze the moon into the position where it always faces, keeps most of that mass facing us. There is another mass underneath a dark spot on the dark far side of the moon toward the bottom where we think a second moon collided with our moon. We think we used to have two moons.
All right. So, I saw your hand go up, and then I'll get you.
Since there's such a thing as a black hole, could is there is it possible that there's such a thing as a white hole?
Yes, is there a possibility of such a thing as a white hole where material is spewing out instead of falling in? And that is one theory for an explanation of where the Big Bang came from. The reverse, energy emitted from another universe beginning our universe. So white holes used to be thought of as mysterious. There, we now know that quasars seem to be early galaxies where black holes at the center of those galaxies are emitting um, material at a furious rate. We also know that pulsars emit things along very powerful magnetic fields in these very powerful beams, and we used to call those white holes. So it depends on what you mean by a white hole. So we now know that we don't call early galaxies with centers of black holes or pulsars white holes anymore, but we do still have the theory that a white hole might explain the origin of our universe or the Big Bang. Good question.
All right. So, we got a question here.
What is your dog's name?
my dog's uh, My dog has fur the color of a pumpkin, so her name is Pumpkin.
Very appropriate for this time of year. All right, so our next online question is, why did they change from using the octant to the sextant?
Oh yeah, the octant has multiple mirrors, and it doubles the angle that you can measure to a nice degree of accuracy. But the early octants had to use very long telescopes to correct for aberrations. Nowadays, they made them much shorter, which also makes them less accurate. So eventually, the sextant, for its greater accuracy, also octants couldn't measure angles more than 90 degrees. And so that's difficult if you need to look at stars farther from your origin point. And so the sextant took over and the octant wasn't used as frequently. There's a very interesting history. If you look up octant on Wikipedia, I just learned all that tonight by doing that before I came here. So I checked that out on Wikipedia, octant.
All right, is there another question out here? Like I said, I'm kind of a T-Rex, so you have to put your hand up and raise it around. Bueller? I hear some crickets. All right, so our next online question, is it possible to see the small planet of Ceres in the asteroid belt between Mars and Jupiter?
Ah, Ceres. I don't offhand know the visual magnitude of Ceres, but I know you can see it easily in a small telescope. And in fact, Stellarium indicates it was recently locatable close to one of the other major planets. So I don't personally, I've never seen it, but I know that if I were to look for it, I could probably find it and see it in a small telescope, but not in detail because it's too small.
Yeah, so I asked some of the guys who actually know a bit more about observing, can you see Ceres from here? And they're like, yeah, but it's just kind of looks like a dot in our
A star.
telescopes because, it's small and far away. All right. So if you guys have questions, again, kind of raise your hand. I'm going to move on to the next online question because unlike you guys, I see most people wearing pants and have cozy blankets, I'm wearing shorts. I did not dress appropriately for the weather. Will they ever do reclassification of moons because of size differences, like the planets? Now there are planets and dwarf planets.
So you're probably thinking about the reclassification of Pluto, and they're curious to know if we'll reclassify other moons or
Yeah, because there's such a big size range from sizes of moons.
No, the classification that reclassified Pluto is kind of vague because it depended on whether an object cleared its orbit of other debris, and you can always find exceptions to the rule, especially in the asteroid belt. But probably not. I have a friend who says we should just call everything a planet. Cometary planets, asteroidal planets, dwarf planets, big planets, because anything that orbits the sun, if it has its own independent orbit around the sun, it's a planet. Our moon does not have an independent orbit. It has a common center with the Earth inside the Earth, a few thousand miles from the center of the Earth. Pluto has a common center with its moon Charon outside of Pluto. The two spin around like a dumbbell. I saw someone with a question.
Yeah, the whole problem of taxonomy. I believe there's a joke in the ancient times where someone said, "Man is hairless, featherless, bipedal," and they took in a plucked chicken and said, "Behold, a man."
Yeah.
So naming and classifying things is
we
fun.
could reclassify the Earth moon system and the Pluto system as not planets.
All right. Here's a question.
Is it possible for moons to have like their own equivalent of moons?
Yes. Yeah, moon of a moon. I believe they found asteroid systems somewhat like that. Asteroids have moons. We've actually seen that. Pluto has multiple moons. But I don't know if we've actually discovered a moon of a moon yet. That's a very good question. I'll check that out.
Inception.
All right, so
We
next
heard you
time,
like moon, so we gave your moon a moon.
yeah, if you're here next time, I'll address you directly, and Otherwise, I'll look that up and I'll mention it in the next What's
This
Up
is
in
great.
November.
People are finally giving him homework instead of us having to do all the
Yeah,
homework.
Very good.
All right. So because I noticed we do have a couple more online questions, but not too many. I do want to put a last call for questions for our online audience, and that's because they're a little bit behind. Streaming delay. It takes a minute for the electrons and whatnot to transmit data. So, like I said, if you do have those online questions, do get those in. Our next online question is: so you told us how long the transmissions take to get to Jupiter, but how long would it take to get to Jupiter in a car going 60 miles per hour?
All right, 60 miles per hour. Divide that into 400, rounding off. 400 million divided by 60 would be 40 million over 6 would be 8 million hours. 8 million hours. There's 31 million seconds in a year, and an hour is 3,600 times bigger. 3,600 years times 8, 2,400 years. All right, so a few millennia.
That's a very long car trip with kids in the back going, "Are we there
Yeah,
yet?"
you'd want to go. You'd want to go in a spaceship, but even then, on a Hammond orbit, which is efficient, that's where you blast off, but you shut the engines off, and then you just coast. So that could take to Mars. It's 250 days. To Jupiter times 5 is several years, even in a spaceship. So what you want to do is develop a spaceship with continuous acceleration. That is where the rocket keeps going the whole time. You're going to need a lot of fuel.
And you also want to develop a rocket that, after it's done all that acceleration, can also slow
Diesel,
down.
right. Very good
Brakes
point.
are important.
Good point.
All right, another question out here. I thought I saw a hand. Bueller? All right, so our next online question is the universe entropic or anthropic?
Anthropic means like human, right? Anthro, human-like. And there is the anthropic principle, which is not really scientific, and that is the universe is designed the way it is because we can observe it. It has to have the right conditions for intelligent life to come along and ask, what's the purpose of the universe? It's sort of the universe becoming self-aware, right? So it really doesn't help us in science discover principles about how the universe works. So what was the other one? Anthropic or
Entropic,
entropic?
which I believe deals with like the inevitable heat death of the universe.
The entropy, yeah. Entropy is the tendency of the universe to run down. What was that? Yeah, losing energy over time. Even though the universe loses energy over time, doesn't mean that things can't get more organized in local systems. And that's why we have galaxies and star clusters and stars and planets and people.
All right. So just to give you guys a couple seconds online to finish up that question, I thought I saw some typing. We do have a couple of observatories open. So each of those little sheds you see has a roll-off roof. Anything with the roof rolled off onto the little stilts is open, and we do have volunteers running that because, yes, we are an entirely volunteer organization, and everything you guys have done, especially including liking and following on YouTube and Twitch and on our social medias, does help us greatly justify our presence, as well as those people who have donated either through the sales desk, because or our Patreon, or even online, does help us greatly, keeping our lights on. Although Dan Kirby, one of our other observers, says, you really need to change that. This is astronomy. You don't want the lights on. He has a point. But it does help us keep going and offer our free public programs from April through October, as well as do our public outreach programs, which we have a few of those coming up. Don't forget, next Saturday, like I said, we are opening early, and we'll be opening for the annular solar eclipse going on. So we do have information available on our website and on our social media pages. So, it looks like that wraps up our online questions. Last call for any questions out here. And with that, thank you, Lonnie, for another great presentation. Thank you for everyone here and online for joining us, and have a great night.
Thank you.